Physics Video Explainer 2, problem number 23. The position of a particle as a function of time is given by position vector equals 5.0 I hat plus 4.0 j hat t squared meters, where t is in seconds. For part A, we must solve for the particle's distance from the origin at times t equals 0, 2, and 5 seconds. For part B, we have to find an expression for the particle's velocity as a function of time. And finally, for part C, we will be solving for the particle's speed at times t equals 0, 2, and 5 seconds. To solve for part A, we plug in our given t values, 0, 2, and 5, into our position function for t. To begin, I've rewritten the particle's position function, and we plug in our values to solve. So for this first one, the 0 will cancel out everything else, meaning at time 0 we are 0 meters from the origin. However, for time t equals 2, given that it does not cancel out, we have to take a few more steps. The first step is simply plugging in 2 for t. As you can see here, that's what I have done. After we square it, which gives us 4, and distribute it into the parentheses, we get 20i hat plus 16j hat. Now to convert this into meters, we have to use the Pythagorean theorem, where we take the square root of each of the parts. In this case, we will take the square root of 20 squared plus 16 squared. That gives us 25.6 meters from the origin at time t equals 2. We follow these same steps to solve for the particle's distance from the origin at time t equals 5, and when we do this, we get 5 squared, and when we multiply that out, we get 125 I hat plus 100 j hat. And for our conversion, we will take the square root of 125 squared plus 100 squared. And when we do this, we get 160.08 meters from the origin at time t equals 5 seconds. For part B, we are looking for an expression for the particle's velocity as a function of time. For part B, it is important to understand the relationship between velocity and position, specifically that velocity is the derivative of the position function. So, to solve for the particle's velocity as a function of time, we take the derivative of the particle's position function. And when we do that, we get that the velocity vector is equal to 10t I hat plus 8.0 t j hat. For part C, we are looking for the particle's speed at specific times t equals 0, 2, and 5 seconds. And to determine the particle's speed at these specific times, we must use our velocity function that we just found in part B. So, to begin, I've rewritten that function, and to solve for the particle's speed at these times, we follow the same steps that we used in part A. So, for time t equals 0, the 0 cancels out again, and we get a velocity of 0 meters per second. For time t equals 2, when we plug in 2 for t, we get 20 I hat plus 16 j hat, and then we use the same conversion before, so we take the square root of the squares of the parts, so we get 20 squared plus 16 squared equals 25.61 meters per second, and when we do this for time t equals 5, we get 64.03 meters per second.